very, very stupid script, but it will illustrate the point that you can upload that script and then do URL brute forcing. Get your favorite interesting URLs file from Nicto, your own files, a dictionary file, and start looking for vulnerable CGI scripts, administrator consoles. This is, I have it online anyways, it's public information. It works, it just works, It's a very simple example. As you can see, I'm just using already existing shell scripting, as HTTP client, small HTTP client, it's already on the camera. You have an HTTP client. Why do you have to write something from the scratch, You don't have to. Also, a lot of embedded devices, unlike websites, well, websites will make the same mistake sometimes, but a lot of embedded devices leak passwords and other sensitive information in the source code. So it might, you look at the page, it might look like the password is masked, but it's actually not. You just have a form that says type equals password, which is not really hiding it. It only hides it from your eye. So the idea is, if you compromise an embedded device like a printer, it's a very good idea to, after you steal the password from, say, the HTML source code, to try the same password on other adjacent systems. Because we're all humans, we reuse passwords, When I'm doing penetration testing sessions, I always reuse a password. If I manage to compromise a password, I will try the same password in every single login interface. I don't care if it's Telnet, I don't care if it's SSH, I don't care if it's terminal services, I don't care if it's BNC, you name it. If you have a service that asking for a password, you try the same password because people reuse passwords, So that's just another example of how compromising a device might lead you to something more interesting, Perhaps this SSH server for backup reasons, I don't know. Just some examples. There are some implementations that leak passwords through SNMP read access. Some people have told me on the internet, this is bullshit, I've never seen anything like that. You're not ever going to get a password through a SNMP read community string. Well, here are the links. There's 1, 2, 3, 4 links. Go check it out. It's public information. And again, just going by the same philosophy of exploiting features that already exist on the router, or whatever device it is. There is a lot of cool stuff you can do. Here I'm mentioning the example of compromising the video page, hijacking the video. Sometimes you have tools that are for diagnosis reasons, So you might have a ping diagnostic tool. Perhaps you want to write a little Python script or Bash script that wraps around the ping tool. So after you compromise the device, you're basically automating the process of pinging internal IP addresses. So again, you're using an internet-facing device as a proxy to probe the internal network. Those are other examples of how you can bounce your connections through embedded devices. And this is the ping diagnostic tool wrapper. So essentially, you're using, in this case, a Zaxel router as a ping sweeping tool, which will allow you to discover internal hosts. Zigzag routers, they leak, at least some models, they leak the dynamic DNS password through SNMP, which is enabled by default. So if the administrator is using dynamic DNS, you can go to dynamicdns.com, you log in with the username and password because they're leaked through SNMP, change the IP address it resolves to. Next time the administrator logs in, the password goes to your system, Another example of some things that you might want to try, So, in summary, what are the different things we found, things that have come across while doing the research? This is a list of them. I will only focus more on some of them because I found some new stuff lately and I want to discuss it as well. I will go through all this stuff now. So these are some favorite things that, after you poke with different vulnerabilities, then you start finding magic combinations, These are some magic combinations. Imagine you have a home router. I like mentioning home routers because we all have home broadband routers, so it's something that we can all relate to, right? Now, most embedded devices, web consoles are vulnerable to cross-site request forgeries, but sometimes this is really kind of like, it's not really that exploitable because you still need the victim has to be authenticated, and if the session has times out, when the request forgery attack happens, the browser will show the password prompt again in order to alert the user that he's about to submit the password again. So it could be a bit noisy. However, say that your broadband router doesn't have any internet-facing services, right? So everything on the one interface is being filtered properly, right? And then you find, say, a request forgery, right? And an authentication bypass. Now what you can do is that through a specially crafted page, now you can make the victim's browser bypass authentication and change things on the router. I will show, this is a real example. Back in the UK, the BT Home Hub is the most popular broadband router. There's about 3 million, between 3 and 4 million at the moment. So some time ago, I was researching it because I had it home, and it's quite a fascinating device. You know, there's a lot of features that you can poke with, and we kept finding vulnerabilities, and then BT will fix them, and then we would find other vulnerabilities, and then British Telecom will fix them again. You know, at least they're fixing them, so it's a good thing. You know, this is check this out. I mean, if you look at the URLs on the bottom, this is a really it's the kind of vulnerability that you might, you will probably find through fuzzing. It turns out that if you append some special characters to the URLs, the web server of the router doesn't ask you for a password, you know? I mean, this is like, it's ridiculous, you know? But it works like a charm, you know? If you look at the very bottom, there's a URL, right? And then you see different parameters. If you need to submit different parameters, again, if you look before the question mark, again, I'm putting 2 forward slashes. That's because by appending different characters, the authentication is bypassed. This would give me the authentication bypass. Then if you combine it with a request forgery, you can fully compromise the device. So request forgery, all it means is that the attacker can predict an HTTP request. You know, there's not a dynamic token that makes the HTTP request look different at different times. The attacker can predict it anytime, right? So we developed a really cool exploit, proof of concept exploit. The victim visits a page, say that maybe you're chatting with a victim, I don't know. Hey, check this out, you know, check out this link. This page basically redirects the victim to YouTube and shows the Techno Viking video. I don't know if any of you is familiar with Techno Viking. No? Techno Viking? No? Come on, this is like, it's quite known in Europe. Anyways, check it out, Techno Viking, go to YouTube, it's good. So the victim is redirected to YouTube just to distract him, right? In the background, what's really happening is the following. Check out, notice the action attribute. That's the URL where the parameters are being submitted to. Notice that after RAS, there's 2 forward slashes. So again, we're bypassing the authentication. If you're curious, RAS stands for remote assistance. It turns out that back then, BT had a remote assistance feature. It's kind of like a backdoor for technicians to remotely fix your router. So maybe my grandma doesn't know how to troubleshoot the router. She calls BT, right? And the lady says, okay, what's your, I'm gonna log into your router and fix it, It's a backdoor, but the user has to enable it, right? You need the user's permission. With this exploit, we're enabling the remote assistance feature. And 1, 2, 3, 4, 5, 6, 7, 8 is the password, right? At that point, the attacker can now log in remotely as administrator and do whatever the hell he wants with the router, Perhaps he wants to change, port forwarding rules. Perhaps he wants to expose an internal host to the internet. It's really up to the attacker's imagination. This is just the script that sends an email to the attacker. If you look at the exploit in the previous pages, there's just a request that's being sent to a PHP script. The idea is that the attacker is notified when the router has been compromised. So the script will email the IP address of the router and just a silly email saying, look, this router with this IP address has been compromised. This is the URL to log in. Have fun, And this example is really the same thing I showed on the Axis IP camera, It's quite scary how many embedded devices are vulnerable to persistent XSS in the logs page. So if you have one, you might want to check it out, I already discussed this. If you look at the URL in bold, this is one of the, you see edit CGI.cgi? That's a CGI script that allows you on Axis IP cameras to edit any file. So by accessing that URL, and using XML HTTP request, we can scrape that page, so you get a password file, and then you send it to the attacker. Again, if you look at the bottom, Bolt's URL, we send response text to the attacker. Response text is nothing other than this. This is the page that allows you to edit any file. And if you look at the red square, this is, that's the encrypted password of the root account. Now whether or not you can crack it really depends on the password length, but you can see that it's not a good thing that if, there's something wrong. Just because the administrator has checked the logs page, someone shouldn't be able to steal the password file, And of course, authentication bypass, if you have access to a service that's listening on the one interface, it's game over as well. This is more of a peculiar example. Yesterday, unfortunately, I missed the presentation about UPnP IGD. I don't know if you guys have seen it. I researched this topic a lot. UPnP is freaking fun to play with. Play with it. There's no authentication of any type. The only research that I had seen about a year ago, before I was poking with this, is from a website which is quite good. It's called upnphacks.org. And this guy, he was researching UPnP, and he noticed there's some cool stuff he can do. So what we did, his research was based on internal attacks. We wanted to find out if it's possible to hack your router through UPnP remotely. Again, we're back to the same sort of attack. The trick is to make the victim visit a page that will make the browser submit the UPnP request. It's easier said than done because there are certain limitations that you need to bypass. You need to understand, first of all, the request that you're sending to the router is model dependent. Universal Plug and Play has something called description URLs. Basically, the way it works, imagine that you're using Skype, right? You're on your laptop, home network, you run Skype. Skype sends a UPnP request. I think it's msearch. Msearch, yeah? Okay. msearch request, multicast. Hello, is there anyone out there supporting any IGD? IGD in UPnP means Internet Gateway Device. That's your home router. Hello, home router, can you speak UPnP? Yes, sure, I can speak UPnP. These are my description URLs, which means, or control URLs. I don't remember the right terminology, but basically it's the different URLs which tells other devices or other systems what functionalities the router is offering, right? And this is really how it works. So if you're attacking a router, you need to first of all know what are the control URLs for that model. And there's public demos on how to fingerprint routers based on unique images not existing. If you use new image statements in JavaScript, you can use the onError event. If it gives you an error, it doesn't exist. Otherwise, it exists, so you already know you can fingerprint the router. So don't assume that your router cannot be fingerprinted. You should assume that when you're browsing the web, remote sites can know what's your router. It's a fact. Just live with it. It's just the way it is. So you need to know what's the control URL. And then, most importantly, the challenge is to be able to fake or forge the post request. Now, the post request is not a standard post request. There's a few customized headers. It's a SOAP XML, right? There's a few ways you can forge this request. One of the ways is by finding a vulnerability in the Flash plugin, right? Back then, we found a way to do it with Flash using actually a function that's there for developers. I think it was sent to URL. I'll show you later. So one way is to use Flash, and if you manage to forge any header, it's game over. You can make changes to the router, right, through UPnP. Also, what changes you can make is also dependent on different routers. So don't just think that it's the end of the world. It might be a bit limited, Now, moving on other type of different devices. Some people here might be familiar with Aruba networks. It's quite big in the corporate Wi-Fi world. There was a really cool vulnerability. This was not found by me, but I think it's really cool. So I'm going to include in the slides because it's quite a good one. There was a persistent cross-site scripting on the login page of the controller. The controller device is in charge of the entire network. So put it this way. If you compromise that device, it's game over in the entire network. It turns out that you can inject anything on the login page, and this is just an example of, overriding the action attribute of the login form. So when the administrator logs in, the password is actually sent somewhere else. And this was confirmed by Aruba networks, by the way, but no one thought it was that big deal. I don't know. It's really trivially exploitable, so I'm not sure. I love authentication bypass bugs because it means that you can compromise a device without a password, obviously. I'm not going to go through different types. I mean, there's some very peculiar stuff that I've come across. Sometimes even changing the method from get to post will allow you to get a config file without a password. I found that in a BT Voyager router.